What's up, guys? Welcome back. In this part, we're going to be covering different variable types, and we're also going to be um, basically we're going to be covering different variable types, and we also are going to be doing like different operations just to show you that it's the same. So, for instance, if you have a variable of, for instance, like z, and it's equal to x plus y, well, this is like math variables here. So this is similar to math class. You see, I'm getting a warning because they're not really defined anywhere. If you hover over that, you can see it. And so what I really want to do is define these first. If I say x is equal to, let's say 2, y is equal to 2, and we say z is equal to x plus y, um, now those errors should go away. Now this type that we just made is called an integer, and it's similar to math class. Basically, an integer could be a positive or a negative, but it has to be a whole number. And so we just run this here. We can print z even though it's a number and it's not an actual word or anything. Or string, which I'll get into in a minute. If we run this here, you can see we get 4. Likewise, if I change this to a negative 2 with a hyphen, and I run it, and you don't have to save it, it'll save automatically. We get 0, because 2 plus negative 2 is 0. So you can see that we can do that there now. What if I change these to strings? So what if I do, and you can do strings either way. You can do it with double quotes, or you can do it with single quotes. And so if I just do this, what do you think the result will be? Is it still going to be 4? Let's find out. We get 22. Now, obviously, 2 plus 2 doesn't equal 22. Right? I might not have been the best in math, but I still know that 2 plus 2 does not equal 22. So, what happened right there? So, what happened was we basically did something called concatenation, which is when we add a piece of a word to it, or a phrase to another phrase. So, we basically took the 2 and we appended it on to the other 2 and we made 22 and it printed it out as a string. So what we really did was we did print 22 like that, and if we run that, that should also work there, as you can see. So that's what we did there. Now, what if, let me just show you another example first. So one of the common things you'll see is hello, and then we can do space and then world. And so then we print Z now, it'll be hello plus space world. So if we run it, hello world. And so now what I want to do is get into another type, and it's called the float. Now, a float basically could be a decimal or a whole number. Meanwhile, a double can just be strictly decimal because it's double, meaning there's numbers on both sides of the decimal point. And the thing about a double is it's usually twice the amount of memory that it takes up inside of the computer system. So next, I'm going to show you. I say 1.2, and let's just make this a 1. So we can add multiple types together here. And if we print Z, we get 2.2. Now, for instance, let me see here. I guess I'll show you that now. So we can also do minus. So if I print that, we should get, yep, something like that. You can see how it rounds close to it. Now, basically what we did here was 1.2 minus 1, but we didn't get exactly on the decimal. We got this weird number right here. We get a 1.999996 or whatever. So I can't quite remember this line off the top of my head, but I think we can actually do something like this. So round Z2. So what this will do is it should round Z to 2 decimal places after the decimal. Maybe that should be a 3 because actually we have to take into account the 0. Let me just check. So you can see here we got 0.2. So if we did round 2, we'll also get 0.2. So basically it just rounds it to like basically like whatever number of decimal places you want. Because this was less than 0, we didn't have to account for the 0. For instance, if this was greater than 0, for instance, And if we round it to 1, you can see we get 1.2. So it's after the decimal point. So basically, that just rounds the numbers for you. So if you want a prettier output, otherwise you're gonna get, you know, uh, this long thing here, and you probably don't want that. So that's something to keep basically to be aware of. So next, I want to show you time. So we don't use the x because that can be used as a variable, obviously. So we use the asterisk. So for instance, if I do, let's say 2 times 2, I should get 4. Um, 2 times 2.5, I should get 5. And you see that it left it as a decimal. Now that's because um, basically whenever we interact two variables and one is a decimal, one isn't, it's going to automatically do a decimal as the output. And that's because that's just like the way it works. So if you don't want that, you would have to like turn it back to an int. So we could do like int z like that, and if we run it, now we get 5. So that would turn it back to an integer where it's just a whole number and it lops off that decimal piece right there. So that's something to keep in mind as well. So now what I want to do is division. So now you have two kinds of division. You have let me just do this here. So let's just say we have 5 and 2, right? So when we divide this, we should get 2.5, 2.5. So when we run this, we get 2.5. Now what if I do a double slash? What do you think is going to happen? Let's find out. So we get a 2. So basically this is called integer division. And what this means is we don't want a decimal back, even if there is a decimal. We just basically want to get the whole number part of it. So if there's anything after the whole number, we just lop it off. So this is the same as rounding down or something like that. Yeah, basically rounding down, I guess you would say. Like if you did, I can't remember if it was long division or standard division, but basically you would have a remainder after you go through the number. And that's basically like the number before the remainder, the actual quotient, but it's not without the decimal, basically. So now what if you want the remainder? So if we do 5 divided by 2 and we get 2, then that means we should have a remainder of 1, right? Well, in order to get the remainder, we have to do something called a modulus. So a modulus basically is just a percent symbol. And they call it a modulus, but basically it's a percent symbol. And we want to use this to get the remainder. So if we just do this, now we can get 1, right? Because that's the remainder. So that's just something to keep in mind. We also have different things like, let me just say, let's make another variable here. Let's say w is equal to x plus y. And let's say z is equal to 0. Print z, and then I'm going to say z is equal to z plus w. So when we print z again, so if we do this twice here, and I'm also going to do another print statement to put a line between it. If we run this, you can see we get 0 and then we get 4. So what happened was x plus y is equal to 4. Z is equal to 0, so we assigned it to 0 initially so that we could see it as 0. Then we set it equal to whatever it already was plus whatever w was, and then we printed it. So you can see here, this might look confusing, like we're setting it to itself, but this is basically how you do addition when trying to basically add something new to a variable. And so this might seem like kind of like a long way of doing it, and it is. There's actually a shorter way to do this. So I could take this same line and just do plus equals like that. So what this will do is still give me the same result. So what I did was this saying plus equals is the same way as that equals z plus w. It's just a shorthand way of doing it. You also have minus equals for subtraction. You have times equals for multiplication, and then division equals for division. So like those are all the same thing. So minus equals is the same as Z minus, and then times, let's see, where is it? Times equals is the same as Z times, and then division equals is the same as Z divided by W. So that's just how that works. So I wanted to show you that. So let me see, what else do I want to do in this video? That should be it for this video. I just wanted to show you different things because I don't want to get into the actual like making a quick thing, like a quick little like project to combine everything we learned until I actually show you how to do loops. And so that'll be coming up in like the control section of this, like the control flow. So thanks for watching this video. If you have any comments, leave them in the comment section, and see you later.